This video is a continuation of transformations of functions, and this time we're going to do reflections. We can reflect a function about the x-axis. Think of it as holding a mirror on the x-axis, and you would see its image reflected on the other side of the x-axis, or we can do a reflection about the y-axis. So think of a mirror being held on the y-axis, and what would that reflection look like? So using the square root function is a really good function to see reflections appear. So let's start off with, on our calculator, let's start off with the square root function. Now to get to that, you have to use the square root down here, which is right above x squared. So I'm going to hit second square root, put in my x, and I only recommend you do this once as you're graphing these things. I would do a zoom 6. If you see option 6, it says Z standard. Just by pressing the 6 will give you a standard window size from -10 to +10 on the x-axis and -10 to +10 on the y-axis. So here's what our square root function looks like. Okay, so that's the standard square root, but let's go and do problem A here, which is what happens if a negative sign is in front of the square root? Right? If your negative appears in front of the actual function itself, it's a reflection over the x-axis. Let's go take a look at that. So I'm going to insert here, and insert is right above delete, so I'm going to second insert, and I'm going to insert a negative. Don't use the minus button. This is a negative that we want to insert, so use the negative down here at the bottom. Okay, if we hit the graph button, we don't have to do a zoom 6 anymore. We can just hit graph from now on. It will give us the standard window size. If you hit graph, do you notice that our square root function just reflected itself over the x-axis? Okay, so that's what a reflection over the x-axis looks like. We could do the same thing with x squared, but if I'm about to do a y-axis reflection, and you'll see that it's hard to see what a quadratic function looks like reflected over the y-axis because it looks exactly like itself. So that's why I'm playing around with square root of x. This time I'm going to delete this this negative here. This time I'm going to do option B, and I'm going to put the negative on the inside of the square root with the x. Now that may be a little counterintuitive to some of you. Some of you are probably wondering, wait a second, you can't have a negative inside of a square root. Well, you're absolutely right, you can't. So in other words, think of it this way. If you give me a positive x value, say 4, right? Say x is 4, and I plug that into this function here, then I'd have a -4 inside the square root, which is imaginary. I can't do that, it's not real. But if you gave me a negative x value, say for instance -9, -9 and this negative here, right, then the opposite of -9, these two negatives would cancel each other out, giving me a +9, and I do know what the square root of +9 is, that's 3. So giving me negative x values, plugging them into this this function here, which I've got b, will actually give me a positive value inside of the square root. That's why if you hit the graph button, you'll see that this is a reflection over the y-axis. Okay, normally the graph moves off to the right, but now it's reflected over the y-axis because now we can plug in negative values for x. They will turn out to be positive values. It's pretty neat. Okay, let's try combining both of them. That's what problem C is doing here. So I'm going to go back here and I'm going to insert a negative. So now my problem looks like negative square root of negative x, right? And that's what I've got going on here for problem C. This is both. This is going to be a reflection both over the x-axis as well as a reflection about the y-axis. Let's go take a look at that. Hit graph, and sure enough, imagine our original x square root function, square root of x, is in quadrant 1 up here, right? If it's reflected over the x-axis, it would be down here in quadrant 4, but then that graph is reflected over the y-axis, so now it's down over here in quadrant 3. So this is a double reflection, both over the x and over the y. All right, and the last two questions here are, what happens if the negative is out front You should now know that as a reflection over the x. And then I've got a plus 6 on the outside of the function. We've looked at this before. This is a vertical shift, right? And because that's a plus 6, it's vertically shifted up. So let's go check this out. I'm going to delete the I'm going to delete the negative on the inside with the x, and I'm going to put a plus 6 on the outside here, outside of the function. And we should expect, right, a reflection over the x-axis and then vertically shifted up. And if I hit graph, we'll verify that. And sure enough, that's pretty exactly what happened. So imagine it, the original square root function being reflected over the x-axis, it would be down here, but then take that function and shift it up 6 places. And that's exactly what we have. All right, so the last problem then is I've got a negative on the outside. This is part E here, question E. I have a negative on the outside. That's a reflection over the x-axis. I have a minus 2 on the inside of the square root directly affecting the x. That is a horizontal shift. I'll mention that, come back to that in a second. And then I've got a minus 3 outside of the square root. That's a vertical shift. So vertical shifts work like we think they do. That's a minus 3, so it's going to shift it down 3. But do you remember how horizontal shifts work? This is minus 2. You might think it moves it 2 places to the left. It moves it 2 places to the right. So let's go try that out. Last one here. Got a negative on the outside. Inside the square root, directly affecting the x, is a minus 2. Add that in there. And then instead of a plus 6 on the outside, I've got a minus 3. So I'll go back and put minus 3. And if we graph this, this should be a reflection and a horizontal shift as well as a vertical shift, and exactly what we want. First of all, it was reflected over the x-axis. Secondly, it was shifted 2 places to the right, plus positive 2. Sorry, this is a minus 2, so it's moving in the opposite direction of what we think. That's shifting 2 places to the right. And then the minus 3 on the outside is the vertical shift, and that's shifting it 3 places down. So there is reflection about x and about y axes.